Chapter 6: How Sex Drives Evolution.
Biologists have come to agree that sexual dimorphic traits violate every aspect of evolution. This is due to the amount of energy and time that a male organism takes to reproduce. On the other hand, sexual dimorphisms will come to benefit many individuals, and we will explain why later on.
What is sexual dimorphism? Sexual dimorphism is when females and males have different traits that distinguish one from the other. This can be features such as color, tail size, and mating calls and/or dances. Although many of these features found in the organisms violate some aspect of evolution, it also helps them have a better chance of survival of actually being able to reproduce. This is where sexual selection comes into play, and it also becomes a subset of natural selection.
Sexual selection is seen in two forms: direct competition and female choice. Direct competition is male-male interaction, and female choice refers to the female's option to choose whomever she wants to mate with.
The first type of sexual selection is most easily seen since males are physically competing with each other to mate with a female. Those males that win have preferred traits that tend to win the female and pass on their alleles to their offspring.
A prime example of male-male competition is found in the elephant seals. Elephant seals show sexual dimorphism in that the males are much larger than the females. Elephant seals are also polygamous, which means that they mate with many different females during their breeding season. When it's time to actually mate, the males protect the group of females that they mate with. Other males that are not as big or agile are left to drift away and probably don't mate at all. These competitions can get bloody as males fight for the females. They use their large teeth and create deep wounds in the opponent's neck. They also mash their bodies together to show their strength or dominance. The winner is not determined until the female hauls out from her group to obtain the winning male, hence a prime example of female choosiness.
Another example is the red-winged blackbird, in which defends its territory in open habitats. This species is also polygamous in that it can have about 15 females nesting in his territory. Half of their life is spent protecting its mate and territory due to other males wanting to mate with the females that they obtain. They often call out as a sign of threat and protection for those males that want to get near its territory.
Once a male has obtained its mate, the male will inseminate the female and allow it to fertilize. He must protect her from other males wanting to remove any of his sperm and not let his energy be wasted. Males must protect themselves from post-mating competition. They have several mechanisms in order to do so. Some species will hang around after mating to physically prevent another male from mating with the female. Others will also release pheromones that keep other males from copulating. One of the strongest defense mechanisms is penis scooping, in which males remove the sperm of a previous mate, giving them a chance to reproduce with the female.
Here we have two prime examples of post-mating defense mechanisms. Here we have the South Central American millipede, which tends to ride the back of the females once they have done copulated to ensure that no other males can mate with this female. And next we have the damselfly, which employs the use of the penis scoop. As you can see, it is scooping out the sperm of the previous damselfly.
The evolution of sex has been one of the greatest mysteries of all, and the majority of species benefit upon reproducing sexually. Reproduction takes about 50% of your genetic contribution for the next generation, compared to asexual individuals. Parthenogenesis is when eggs are produced without fertilization. Many species also contribute to this phenomenon. Sexual reproduction allows for recombination of genes and variation of species.
The evolution of the two sexes has come to differentiate in mating strategies. For males, they have the advantage to produce larger quantities of sperm, which gives the male a huge advantage to produce a high number of offspring. For females, eggs come more expensive, and these eggs are very limited in number. Therefore, it is not beneficial for a female to reproduce great quantities of offspring because it won't do much to her fitness. These mating strategies offer different investments for their offspring. For females, mating is expensive, and for males, it is rather cheap. Male investment is cheap due to the small cost of producing high quantities of sperm. Males don't have much to lose when it comes to mating. They can easily mate with various females whether they are healthy or not.
Males are not choosy since they can produce a greater number of offspring. Females must be choosy since they invest so much more time and energy into producing and caring for their offspring.
Sexual dimorphism can be violated between the mates. Some species have larger females and are more decorated than the males. Males also have a greater responsibility and are limited by caring for their offspring. An example would be seahorses and their close relatives, in which they become pregnant. In this case, the males invest more energy on parenting than the female does. Males carry the eggs once the female has produced them, and the male has fertilized them.
An example of a violation of sexual dimorphism is the fairy wren of Australia. This species is socially monogamous in which the male and female pair up and rear young together. In this case, males and females spend most of their energy protecting their territory and offspring. The male shows sexual dimorphism in its plumage, but it doesn't serve a real purpose since the female will go and mate with other males during mating season and not with her social mate.
Female choice is based on certain characteristics and behaviors that attract a female to mate with that specific male. These traits are color, ornaments, size, singing, and bowers. These traits vary among males within a specific species. These variations are what allows for females to be very choosy when choosing their mates.
Peacocks are a great example of mate choice. Studies have shown that this species forms leaks. Leaks are areas that peacocks can display their feathers at close proximity. This gives the female a better chance to choose their mate. Researchers have proven that there is also a correlation with eye spots in the peacock's feathers, suggesting that females prefer more elaborate tails. Here's an example of a peacock showing its full plumage, ready to attract the mate.
Researchers have noticed a correlation between number of eye spots and number of offspring. To test whether females prefer more elaborate tails, researchers conducted a study in which they reduced the number of eye spots on some males, increased the number of eye spots on others, and kept the control group. They observed a decrease in the number of offspring of those with less eye spots, an increase in number of offspring of those with more eye spots, and no change in number of offspring with the control group.
Another study was done on widow birds. These birds contain long tails which attracts the females into mating. To test whether females chose the elaborate tails, researchers created fake tails that were glued on the birds as well as using the other birds which had shorter tails. They were able to find that the fake bird tails mated more than the ones who had shorter tails.
So here we see the widow bird with the long tail as the female is attracted to. When it comes to female choosiness, there are both direct and indirect benefit. Direct benefit is when the female chooses a healthy-looking male and gives her a healthy offspring. Indirect benefit would be the female choosing a male who has genes that are superior to other males, which would result in her offspring having better genes as well.
There is a third yet simple explanation for sexual dimorphism. It is based on sensory bias models, which assume that the evolution of sexual dimorphism is driven by female biases in a female's nervous system unrelated to finding a mate, maybe like finding food. A female may have a preference for yellow-colored food, and a male mutant may appear with a yellow dot on his chest. Yellow males would have an advantage due to a pre-existing preference of the females preferring food of this color. There could be other features that stimulate their nervous system, such as bigger males or those who have complex dances. These models do not have a direct or indirect benefit for the female choosing this male. However, they do show why there would be a difference between physical characteristics between a male and a female.
In conclusion, the evolution of sex plays a great role in the reproduction of offspring. It is responsible for the vast variation we see among species today. Sexual dimorphisms help us to understand the difference between males, females, and their different characteristics. Mating is expensive for females and cheap for males due to the difference in investment each sex has. We must keep in mind the importance of sexual reproductions for generations to come.